Hello everyone, today we're going to resolve the daily LeetCode problem number 2845, Count of Interesting Subarray. So it's another count problem where we will be counting something, so count will be equal to 0 and we will return our count. So the idea here that we're given a 0 indexes integer array nums and two integers, an integer modulo and integer k. So our task is to find the count of subarrays that are interesting. What they mean by interesting? A subarray nums from left to right is indexes from left to right is interesting if the following condition holds. So let's count with the number of indices I in the range left and right, such that nums I modulo'd by modulo equal k, then count modulo'd by modulo equal k. So we need to return the notion the count of interesting subarrays. So subarray is continuing non-empty sequence of element within array. It's a recommendation, and we have examples. So array nums 3, 2, 4, modulo 2, and key 1. We have output 3 because in this example the indices of array are from num, which is 3. This is only one index I equals 0 in the range 0, 0 that satisfy numbers modulo by modulo equal k. Hence count equal 1 and count modulo by equal k, the subarray nums from 0 to 1, which is 3 to 2. There is only one index in the range of 0 to 1, that is 5 nums modulo by modulo equal k. Hence ctn equal 1 is the modulo of count modulo of modulo equal to k as a subarray nums 0 to 2, which is 3 to 4. There is only one index I equals 0 in the range of 0 to 2 that satisfy numbers I position modulo by modulo equal k. So hence count equal 1 and count modulo by modulo equal k. So it can be shown that there are no other indices of array, so the answer is 3. And we have another example, and we have constrained that pretty big, so brute-force approach wouldn't do here anything. So let's think about this in a way of a story. So imagine you are playing a counting game with numbered cards in a line. You have two specific rules. A card is active if its number, when divided by modulo, leaves remainder of k. So we have conditions. And a continuous block of card is entered it after counting how many active cards it has. That count when again take modulo comes out exactly k. So we have active even if count. In both cases, modulo of them will be equal to k. So you want to know how many blocks of card satisfy this? Checking every possible block one by one is like walking the line for every start and end. Slow if you have many cards. Instead, you keep a running prefix, count of active cards, modulo of modulo. After each new card, you know the current prefix reminder. An early prefix with reminder current minus k mod of modulo signals a valid block from the early position to here. By keeping a map of how many times each reminder has appeared, you can instantly count how many valid stars exist. Then update the map and move on. One pass, one mat, and you have counted all interesting blocks in a linear time. No backtracking needed. So from the idea that I described, story, you understand that we will use prefix-sum and we will use hash map for our counting, and time complexity from linear search would be equal to of n. So we pass through all numbers and space complexity be equal to big of minus of n modulo. So storing at most one frequency per reminder. So in the worst case scenario, it will be also big of n, but in general it's reminder between modulo and n. So we will start by declaring our prefix, which should equal 0, and we will need our hash map, which will be modulo of frequency be equal to 0 from position 1. So we make one empty prefix with reminder 0. Then next step, we will loop for num in nums and check if num modulo'd by modulo equal k. So if this card is active, so bump our running count and wrap by modulo. So for that we will use prefix mod, which will be equal to prefix mod plus 1, and we will modulate it by modulo. Next step, we will need search for reminder for needed elements, and it will be prefix of mod minus k and modulate by modulo. Now we can update our count by adding needed 0 by adding of needed reminder elements, and then we ensure updating of our map, which will be equal to frequency.get prefix of 0 plus 1. And lastly, we will return our count. So let's run this and pass it and submit. And it's almost 99% of runtime. So the main idea is here that we use prefix-sum and hash map to store key value pairs. Prefix will be used with modular. The main idea that we need in every step module elements. We need module our element, and we need module our prefix mod also. So we often use module because it's our conditions. And after that, we will count them and update our count by mod_freq that equal to get needed element, the reminder element. And we return that, making it easy in one pass. So thank you for your attention. If you have any questions, feel free to leave them down below. Have a nice day. Bye.